Hello children, welcome to Minutes of Maths. In today's class, we are going to solve question number 2 from exercise 1.1, class 10, chapter 1, real numbers. The question is, show that any positive odd integer is of the form of 6q plus 1, 6q plus 3 and 6q plus 5, where q is some integer. That means we need to prove if the given number is positive odd integer, then we can write those number in the form of 6q plus 1, 6q plus 3, 6q plus 5. So what we are going to do first, let's see the form 6q plus 1. This is in the form of right hand side of division algorithm, isn't it? What is the division algorithm? A, any integer A is equivalent to divisor B, quotient BQ plus R remainder, isn't it? Where R is lesser than, greater than or equal to 0 or lesser than B. This we know. Now, what we are going to do, we are going to assume let A be any positive odd integer, because we need to prove odd integer can be written in the form of like this. So, let A be any positive odd integer and where B is what in this, you can see this is in the form of BQ plus R. So where B is 6. If B is 6, then what is R? R value will be greater than or equal to 0 or lesser than 6, because B is 6. So that I have written R should be greater than or equal to 0 and lesser than B. Here B is 6. So now we are going to write equation A is equivalent to 6q plus 1. This is not 1 R, 6q plus R. This is our equation. Now what we are going to do, we are going to substitute R values. What are the R values? R is equivalent to 0, 1, 2, 3, 4, 5, isn't it? Because R should be lesser than 0, equal to or greater than 1. So that R we have 6 values. First we are going to substitute R values one by one in this equation. When R is equivalent to 0, what is our equation? A is equivalent to 6q plus R. In this equation, we are going to substitute R value. So, plus 0. So, which is equivalent to A is equivalent to 6q. Got it? Next, when R is equivalent to 1, what is our equation? 6q plus R is 1. So this is our second equation. When R is equivalent to 2, A is equivalent to 6q plus 2. When R is equivalent to 3, A is equivalent to 6q plus 3. When R is equivalent to 4, A is equivalent to 6q plus 4. When R is equivalent to 5, then A is equivalent to 6q plus 5. Got it? We have substituted all the R values in this equation so that we have got new 6 equations. Now we have to analyze this equation. You can see A is equivalent to 6q. This is our first equation. What is 6q? Already here they have given q is some integer. If any integer multiplied with the even number, then the product will be even number, isn't it? We have written A is equivalent to 6q. That is, the product of 6 and q is A. Then A would be even number, isn't it? The integer q we need to multiply with the 6. If any number multiplied with the even number, then we will get the even number as the product. So that I am saying in this equation A is even. Now we'll go to second equation. Here A is equivalent to 6q plus 1. Already we know 6q is an even number. Now we are going to add 1 to this number. Then what is our A? Odd. How? We know if even number is added to the odd number, then we will get a odd number only. For example, I'm going to take even number 4 and odd number 1. What is the sum of these two number? 5. We have got a odd number. So if any even number is added to any odd number, then the sum will be odd number. So that we are writing equation in equation 2, A is odd number. Similarly, you can see third equation, A is equal to 6q plus 2. Here 6q is even number, we know. In this case, we are going to add 6q to the even number even number 2. So we'll get the even number, isn't it? In this case, A is even. Next, 6q plus 3. 6q is going to add it to the 3. Then the sum will be odd. Here 6q plus 4. This is also even and this is also even. Then the sum is also even. In this case odd, because even number going to add it to the odd number 5. So the sum is odd. So you can see this one 6q and 6q plus 2, 6q plus 4 are all even numbers. So this is not in the form of 6q plus 1, 6q plus 3, 6q plus 5. Hence we have proved if A is odd, positive, integer, then we can write A in terms of 6q plus 1, 6q plus 3, this one, and 6q plus 5, last one. Got it? Hence, we have proved. In this way, we need to prove this type of question. For example, if I change the question like this, see, show that any odd, any positive, even integer is of the form of 6q plus 4 and 6q plus 6. Got it? 6q or 6q plus 4 only. Here we have missed one. 6q plus 2 instead of this one. So, if they ask like that, we will take these three. 6q plus 2, 6q plus 4 instead of 6q plus 1 plus 3 plus 5. Got it? Thank you.